Use the rational root theorem to find the factors of this polynomial. According to the rational root theorem, if a polynomial has rational roots, then they are based on the factors of the coefficient of the leading term and the factors of the constant term. The leading coefficient is labeled q, and the constant term is labeled p. If rational roots exist, it'll be the ratio of p over q for some values of each term. In this example, the leading coefficient q is 1, and the constant term is -6. What are the factors of q? In other words, what numbers divide evenly into 1? There are just two factors, plus or minus 1. What are the factors of -6? What numbers divide evenly into -6? Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So the ratio p over q is all combinations of these factors divided by these factors, which is summarized here. So the possible roots are plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. Let's use synthetic division to test these possible rational roots with this polynomial. Start by inputting the coefficients of the polynomial here. So we input 1, -1, and -6. And let's try x equals +1. So we bring down this value, multiply it by the 1, and put the product here. 1 and -1 is 0. 1 times 0 goes here. -6 plus 0 is -6. Since this result is not 0, x plus 1 is not a root. So let's try x minus 1. We'll put -1 here, the coefficients of the polynomial here. Bring down the 1, multiply it by -1. We get -2. Multiply -2 by -1 to get 2. -6 and 2 is -4. This also is not 0, so this is not a root. Now let's try x equals 2 as a root. Place the coefficients here. Bring down the 1. 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2, and we get -4. So +2 is not a root either. Let's try -2. Here go the coefficients. Bring down the 1. -2 times 1 is -2. -2 and -1 make -3. -2 times -3 is +6. These two terms do equal 0, so x equals -2 is a root, and this can be rewritten as x plus 2 equals 0. So this polynomial is x plus 2 times, and here are the coefficients for the other term, x minus 3.